Hello, welcome to LeetCode Solver. Today we are going to solve 23rd problem in my LeetCoding challenge, and the problem name is interval list intersections. Interval list intersections given two lists of closed intervals. Each list of intervals is pairwise disjoint and is sorted order. Return the intersection of these two intervals lists. Formally, a closed interval AB where A is less than or equal to B denotes the set of real numbers x with A less than or equal to x is less than or equal to B. The intersection of two closed intervals is a set of real numbers that is either empty or can be represented as a closed interval. For example, the intersection of 1, 3 and 2, 4 should be 2, 3, I guess, here 2, 3. And example is this disjoint. All the interval has a disjoint in A and in B sets. A sets is 0 to 5, 10, 0 to 5, 10, 13 to 23 and 24 to 25. And in B set, which is also disjoint, 1, 5, 8, 12, 15, 24, 25, 26. These are two sets that will be provided, two sets of interval objects. Now I have to return the output, which is the intersection of these two interval lists. Okay, the interval which is overlap between A and B can be found here, which is 1, 2, okay, and then after 5, 5, and then after 8, 10, and then after this one, which is 15, 23, and then after this interval 24, 24, and another 25, 25. Okay, remember the input and the desired output are list of interval objects, not the arrays of the lists. Not arrays or lists. Okay, nice. The A dot length is 1000, B dot length is 1000, A start AI, BI small is 0, maximum is 10 to the power 9. Okay. Well, so what I'm thinking is just as the given interval are already sorted in increasing order, okay, and they are disjoint. This is the good thing. So they are disjoint, then they are sorted accordingly, and B is also sorted, and B among themselves are disjoint, so there is no overlapping among themselves. So what I'm thinking is like, if we kind of merge those two interval, and while merging we can figure out what is the intersection of in between consecutive interval. Like if we try to merge these two lists of intervals, then what happens in sorted order? Definitely, first of all, this interval will arrive 1, 3, then after we will try to compare this and this 1, 3, 0 to 0, 2 and 1, 5, 0, 2 and 1, 5. Among those two things, we can see that this 0, 2 is the earliest one, is the smallest one. So we'll pick up this. So we are kind of sorting to intervals. So we'll take 0, 2. Now in the next move, we have to compare 5, 10 and 1, 5, because 0, 2 is already taken. And while comparing 5, 10 and 1, 5, we see that 1, 5 is the earliest. 1. So we'll take 1 5, and if both of them matches, then we can take any one of them, like 1 5, and there is 1 6. Then I think based upon the last one, we can take 1 5. Then after we can take 1 6. Okay, and we take this one, and then after we have to compare with 5 10 and 8 12. We see 5 10 is the smallest one. We take 5 10, and then after we take 8 12. In this way, the normal way of merging integers, while doing merging of two sorted integers, we will compare uh, the position of still not taken index of both a list, and then after we will compare them and take the smallest one. In the same means, we will take the interval over here as well, and while taking the interval, uh, like we'll compare the intersection in between them. So as we have 0 2 and 1 5, we will decide the what is the intersection in between 0 2 and 1 5, and after that we will decide what is the intersection. We will take the minimum one, and then after we will decide what is the intersection between 1 5 and 5 10. So in this way we will proceed. So let's define added size n, the size of first interval, and as the the interval itself are sorted, and we will be just iterating one time, so complexity would be big O of n plus m, big O of n plus m, as we will be iterating only one times. This is the time complexity. Now let's put a pointer over there for both interval. Say I is 0 for first interval, j is 0 for second interval, and while I is less than n, and both should be satisfied. If one of them becomes, go till the end, then we can't find any. So j is less than m. Now we will have two index I and j, whose we have to find the intersection of two intervals, a of I and b of j. These are the closest one. These are the consecutive ones. So let's find the intersection among them. So in order to find the intersection, we will just find the x corner and the left corner and the right corner of the interval. So say left corner will be the if start and end are there, then we have to take the start, which is maximum among both uh, intervals. So maximum of a of I start, which is the basically vector, and b of j start, which is first index of the vector, left corner, and we will find right corner, left end or right end sounds more good name. So say left end and right end. Right end can be found by taking the minimum among the right end 1 and j1, maximum among starting point and minimum among ending point. If we take this, then we will find the interval in between two interval. So if we see that somehow our left, if they are not there is no any intersection, then what happened is like always left end is less found to be greater than right end if interval are disconnected. In this point, if they are disjoint intervals, then we always see that like this is first interval and this is another interval, then we are taking the maximum among both of them is a left end. So maximum is this point, so we will take is a left end, and we will take minimum among both ending position as a right end. So this is a right end here, so minimum among this and this is that one. So we found that left end is greater than right end, so at this position we have no any intersection. So if left end is smaller than right end, then we will have intersection. So in this situation, say this is a position, then we can find intersection over here. So we'll first of all we'll find the maximum among both starting position, which is basically this is a maximum, so L is over here, and we will find the minimum among ending position, this and this. Among this and this is the minimum one, so this is the right one. So we will find the interval, which is the overlapping interval in between two intervals. We found a overlapping intersection of the intervals. Well, in this way we will calculate the interval. So if the condition that left end is less than or equal to right end, if this satisfies, then there exists an intersection. So if there exists an intersection, we will push it into our answer. So let's make a answer which is a vector of two numbers included in our answer. So let's return a vector in this case. So answer dot push back a vector. A vector can be initialized just by putting in a curly braces. So we form a vector of two number and put it into our answer. Well, now we have to move. Now let's move by just comparing. We can just compare one of the things, like if we found that a of I 0 is less than b of j0, then I is the smallest one. Let's increment I, that means the smallest one was taken. Let's increment I, otherwise let's increment j, and finally we will return our answer. Compilation error. Okay, let's submit. Wrong answer. Okay, 3, 5, 9 to 20. Our answer counted up to 11. Okay, okay, I have to compare the ending things together if they are equals. Well, I can simply do this like if a of I1 is smaller, so we'll compare by ending. Yeah, comparing by ending uh, position of the interval makes more sense over here. Let's try with this input as well. Okay, 1620. Well, this is accepted. Well, the only things is that while finding or while arranging or merging the intervals, we need to care about the ending position of the interval. So whichever ends earlier is the one which is the smallest interval. Whichever ends earlier, we have to take that one into account. Okay, thank you so much for watching this video. And I think I already mentioned the time complexity. The space complexity is uh, the one we used for holding our answer. Apart from that, we haven't used any extra space. So we can also say constant considering, I mean, the answer itself should be, I mean, if any means, if we can say that the answer is not considered as extra space, then we can. Otherwise, we as we are using answer as holding our all the intervals, we can say this is kind of big of n plus m as well, because in worst case complexity we may have intervals in every consecutive sorted intervals. Well, thank you so much. Hope to see you in the next video.